All right, so you guys have your calendar. Today is Wednesday. We're supposed to be on 2.3, but we're still on 2.2. So we got to finish up 2.2 here. All right, so how do we take, so this section is all about graphs and functions. How do we take a graph and answer function questions? The main thing you got to remember is whatever's in the parentheses is x, and the answer is y. That's like the key to answering function graph questions. Whatever they put in the parentheses, they're really saying, hey, that's x, tell us the y value. So they're saying, hey, go to the graph, find the point that has an x value of 8. Well, it's right here. And give us the y value that goes with it. Okay, 6. Boom, that's it. So there's nothing to do, it's just reading the graph. They just want to make sure you can read a graph in function notation. Does that make sense? Let's try the next one. So this is the x value, -6. And so they're saying find the x value -6 and give us the y value, because the answer is always the y. Give us the y value that goes with it. So x -6, y is 0. So again, no manipulations to do. It's just reading the answers off the graph, learning to speak the function graph language, basically. Is that good so far? There's more questions. Let's see. They say, is f of 18 positive or negative? So that's the next question. F of 18, is it positive or negative? So look at that. Let me give you a second. See if you can answer that. The key is, remember, what is the 18? Is that an x or a y? Yeah, it's always x, so that's the key. So go to where there's an x value of 18. Now, there's not one listed, but you can see about where that dot is, right? Where would the dot? So this is x 16. This means this is 16. These are going by 2s, aren't they? Because this is 12. This must be 14. So the 18 must be here. So the 18 dot's right there. They're not highlighting it or showing it. But that must be the dot over 18. And what is, that's the x. What's the y coordinate with it? Positive or negative? Some kind of negative something or other. The y is. So it must be negative. Good? Reading the graph's okay? All right. Plug in is x, answer is y. So let's go back over here. How often, reading right here, how often does the line x equals 5 intersect the graph? Okay. How often does x equals 5 intersect the graph? Well, x equals 5, this is the x-axis, as it says, and the y-axis. So you've got to draw a line that goes through the x-axis at 5, huh? So again, this is 2, 4, 6, 8, 10. So where's 5? It's about right here. So there's the line, x equals 5. How many times does that intersect the graph? Well, only once. One time. Like that. Good so far? Okay, so they're saying f of x equals 6. What is x? So, let me let you think about that one. So again, the plug-in is x, which means, and the answer is y. So the 6 is the y. So they're saying go to that graph, find a y value of 6, and give us the x value going with it. So right here is a y value of 6. What's the x value going with it? 0. That's not the only one, though. Here's another one, huh? Y value 6, there's also 8. 0 or 8. There's two points that are at a height of 6. This is going 2, 4, 6, 8. There's 2 points at a height of 6, aren't there? One's at x 0, one's at x 8. So there's 2 x answers. Just separate them by a comma. Good? And last thing I think is domain. Last question for this one. Domain of f. What does domain mean? Yeah, it's the values. So graphically, we have a picture on this one. Graphically, let me kind of erase all the mess. Graphically, domain means the width coverage. So domain would mean how far, how wide does the graph go? That's the domain. Domain, remember, is the x values, right? This is the x-axis. Domain is the x coverage. I think yesterday I said the possible x values, same thing on a graph. That's the width, right? The x values is the width. So basically, they want you to go left edge, comma, right edge with parentheses or brackets. In this case, it'll be brackets. So what's the left edge? -12. The right edge, 22. Brackets because it's straight on solid dot at negative 12, straight on solid dot at 22. So there is the domain. Good on all that? Reading off the graph? All right. So they're giving us this picture. First thing they say is it a function? That's, you can't see it on the screen on the side, but it's right here. Is it so the first thing is to determine is, so part A, or not even part A, it's right over here. They don't even call it part A, whatever. They ask, is f a function? Remember what we talked about being a function? So we're not going to, for a graph, you just do the vertical line test, huh? Remember the vertical line test? If any vertical line hits 2 points, then it's not a function. So there's a vertical line hitting 2 points, not a function. So our answer is no. So this graph is not a function. You don't ever want any vertical line hitting 2 points. Why? Remember the definition of function yesterday? One x value can't go to two y values? Well, because you see that would be the, whatever that x value is, I don't know what it is, maybe it's over 3, down, I don't know, I'm guessing like down 4, and this is over 3, up 4. See, they have, when you have a vertical line, those are the same x value, aren't they? Leading to two different y values. That's why the vertical line test is the same thing as saying you don't want one x leading to two y's. So, all you gotta do is, if any vertical line hits 2 points, that's not a function, so that one's no, not a function. Next question. Part A, what's the domain and what's the range? So what's the domain? Now, this is a bad graph. Bad in the sense that I don't see arrows on the ends there, but I think they mean for us to assume arrows. I'm like 99% sure. They mean for you to understand there's really arrows. I'd be more clear on a test. I'd put them in there. So let's assume that's the truth. I'm sure it is. They really want you to, they don't end. Whereas the last graph, see how that clearly ends. See these dots, these solid dots, that clearly ended on the left and the right. It didn't go on and on. So when they asked me domain, I stopped on the left, I stopped on the right, bracket negative 12 to 2. Right? Whereas this one, the arrows go on and on. So what's the domain of this function? Well, the domain would be like, the domain's like if you're a person, walking around on the x-axis, where would you see graph? That's domain, right? As you cruise back and forth on the x-axis, where do you see graph? Well, you would see graph from here that way and from here that way, but not in the middle. You with me? So that's the domain. How do we say that? Well, this is negative infinity, because it keeps, these arrows, it keeps going and going, right? So negative infinity up to, what is that spot there?
2.5.
Isn't it 3? Aren't those going by 2s?
Yeah, it's going by 2.
So it's like 2, 4, looks like 2s, I think, right? 2, 4, 6, 8, 10, yeah. So this is negative 2, negative 4, negative 6, negative 8. Anyway, so it's hitting at negative 3. So it looks like negative infinity to negative 3 united with, and then this is 3 to infinity. Is that good for domain? Everybody see that? It's this and it's this. So that's the domain. And then what's the range? Range is the vertical coverage. So if you're a little person walking up and down on the y-axis, you could do that. That'd be tricky. Now, if you walk up and down like that, where would you see graph? Everywhere. Right? There's graph all the way, right? There's graph all the way up and all the way down, corresponding to the y-axis, right? Negative infinity to regular infinity. We good there? Does that make sense on the range, right? You'd see graph all the way up and all the way down, no gaps. Good like that? We good? So that is the range on that. All right, now, question B, the intercepts, if any. They're just asking us a million questions about the graph, so I'm going to come up here to B. What are the intercepts? That means the places where the graph hits the grid system, right? We kind of get rid of all this. So where does the graph hit the grid system?
X.
Yeah, just right here and right here. So what are those points? That's the point back 3 up 0 and over 3 up 0. Right, this dot is back 3 0. This is over 3 0. We good so far? And then question C. Stop me if you want to talk about it. Question C. Any symmetry. Symmetry means same, right? See how the graph is the same on both sides of the y. It's like the y-axis is a mirror, huh? So that's called y-axis symmetry. On that, it's also got x-axis symmetry, right? It's the same to the right and the left of the y-axis. The y-axis is like a mirror, but it's also the same top and bottom of the x-axis, isn't it? Top and the bottom of the x-axis is also like a mirror. It has both y-axis symmetry and x-axis symmetry. This one does. It's a very symmetrical graph. And there we go. That's all their millions of questions. Questions I can answer on any of those? Are all those okay? You okay with the domain and the range and all those other things? All right.
So the answer to C is, if they're both x and y, then would it be origin?
No, origin's something different. We'll get to an origin example in a minute. I haven't explained what that is. This one just has x-axis and y-axis symmetry. We would answer both. I don't know exactly.
Problems.
Yeah.
Let's go to 10.
All right, so there's that one. And they're going to ask us a whole bunch of questions again. I'm not going to do them all this time. But let's talk about symmetry. This would be a good one to talk about symmetry on. All right, so yeah, this one is origin symmetry. This is what it means to have origin symmetry. Let me explain. Let me explain first off why it doesn't have x-axis or y-axis, then we'll talk about origin. It doesn't have x-axis because, like, if you tried to make the x-axis a mirror, it should be down here, and it should be up there, and it's not. Right? You can't reflect across the x-axis. Its reflection does not exist across the x-axis, right? Not in the right spot, right? You know, if they gave me a graph like this, then I would say, yeah, that's x-axis symmetry. It's reflected directly across the x-axis. So they didn't. It's not. Okay, now is it y-axis? No, it's not y either, because if you did a y-axis, it'd have to be over here, and this part would have to be over there. And it's not. It doesn't reflect directly across the y-axis either. So it doesn't have x, it doesn't have y. What it does have is origin. What does origin mean? It means, I'll tell it to you a couple different ways. 180-degree rotation back onto itself. Another way you can say it is 2 quadrants away. It's the same. That's what 180 degree, right? 180 degree means halfway around. So that means if I took this graph and I flipped it halfway around, like if I took my paper, my calendar of our stuff, and I flipped it halfway around, that's 180 degree rotation, right? So if you took that graph and you turned it halfway around, it would look like nothing had been done, right? If I turned this whole thing halfway around, the graph would look the same. This part here would go down and be right here. And this part here would come up and be right there. It would look like I hadn't turned it at all, right? Okay, let me just do it on my paper here. All right, make sure you actually see it. So, with my great artistic skills, I got a C in art in intermediate school, 7th grade. That was the end of my art career, and I was trying. All right, so if you took that graph, it's the right graph, right? Down first, then up, yeah. And it goes down, notice it goes down first, then up, just like that one. And I flip it halfway around. Still going down first, then up. So that's called origins. I mean, that's a 180-degree rotation, 2 quadrants away, right? Because this first this is quadrant 1, quadrant 2, quadrant 3, quadrant 4, right? 2 quadrants away in the first quadrant, 2 quadrants away in the third quadrant. It looks exactly the same, doesn't it? So that's called origin, 180-degree rotation. So I mean, why they call it origin is you might instead of just like 180-degree symmetry, that is because what they're saying is any point shot through the origin exists the same distance on the other side of the origin. What do I mean? So take any point you want. Take that point. shoot it through the origin. Here's the origin, like a target practice. Shoot it right through the origin. It lands right there. Same distance to the other side. It has a corresponding point. Take this one. How about this? Shoot it through the origin, same distance other side, boom. And on you could go. All these points shot through the origin will become all those points. Same distance to the other side of the origin. Going through the origin, going through the middle of the graph. That's called origin symmetry. All right, we good with that? There's no other, got a couple different wrinkles. Let's try it. Okay, so again, that one is a function. Every vertical line here hits only one point, right? Every vertical line you want to make is only going to hit one time, not two. So that passes, it passes the vertical line test. You don't want vertical lines hitting 2 points. So that's good. So it's a function. So then we have to answer the rest of the questions. Yes, it's a function. So now, what's the domain and the range? Let me let you try that. Go ahead and figure out the domain. It's nice they're giving us the arrows this time. Find the domain and the range. So remember, domain is the width coverage, left edge, right edge. So the domain, left edge, right edge. So how far left, so you're a little person walking around on the x-axis, how far left, how far right can you walk and you see graph? Well, you can go left forever, because this graph goes down and left forever, good. But how far right can you go? Just to 0, huh? Now, can you hit 0 straight on the money? Just get close to it, huh? Because you can tell this graph is getting closer and closer and closer to 0 forever, but never touches it. So from negative infinity to 0, parentheses on both, right? Not brackets. Because remember, brackets, if you have a straight bracket like that, that means you're straight on the number, whereas parenthesis, you're just close to it. Remember that from your algebra days? So it's parenthesis there. And then how about the range? The range is... So the range is instead of left, right, it's bottom, comma, top. The range is, up and down. So the range goes like that. So you're a person walking around on the y-axis up and down. How low can you go and how high can you go and see graph? Forever, huh? Negative infinity to positive infinity. Goes down forever, right? This graph goes down forever and up forever. Good on all that? Any symmetry? There goes Roberto, our friendly neighborhood tutor. I saw it. He's a hound dog for attention. He says, Mr. Can you always point me out, please? I'm just kidding. No, see you, Roberto. Have a good day. Anyway, but he's there for tutoring, so his hours are in the back. If you need tutoring, he's checking in with us every now and then. Just want to let you know that he's there to help. All right, so bottom and top. Where are we at? Oh, symmetry. Yeah, does that have any symmetry? No, there's no symmetry, right? There's no reflection across the x-axis, y-axis, or any other axis. Oh, there's one intercept point, huh? Somewhere. Wherever that is.
Negative 1, 0.
That what it is? Yeah, it's right. Looks right. So the intercept's negative 1, 0. All right, I'm going to move on. I think we're good with that, right? Let's see. All right, so it's the point. Okay, so this time they're giving me a function, no picture. So they're kind of changing the game here a little bit. No picture. F of x equals 4x squared minus x minus 3. Give me the function, no picture. And they're saying, all right, is the point negative 1, 2 on the graph? How do I figure that out without a picture?
Plug it in.
Plug it in, huh? This is, so negative 1, 2 is x and y. So put negative 1 in for x. And what's y? Where does y go? F of x is y. Remember, function values are always y values. That's by common agreement in the math science world. F of x, g of x, h of x, those are all just y. So this really says y equals 4. They just agreed that function values would be y values. So plug in the 2 there. Plug in the x. Plus 1 minus 3. What is that? 5 minus, oh, it's 2. Yeah, it works, huh? So it comes out true, so we'll say yes. If those had come out not equal, we would say no. So that's on the graph. That's how a point gets on the graph, right? That's the membership requirement for being on the graph. So B, if x equals 2, what is f of x? So let's just plug into, I'm going to skip that. C, f of x is negative 3. That might be a little more work. Yeah, that is more work. So let's take this function. They want me to put f of x negative 3 in there. So negative 3 equals the f of x. We good so far? See what I did there? I just took that negative 3 and I plugged it in for f of x. And now I need to solve this equation for x. What should I do? What did we learn? What do we know about solving x squared equations?
Have to get 0 on side.
Yeah, got to get a 0, huh? So solve an x squared with equals, step 1, get a 0. So get a 0, so add 3 to both sides. So 0 is 4x squared minus x. That's kind of nice. Now you factor it. How do you factor that? It's not 3 terms. That's not FOIL. It's just 2 things. So what do you do to factor? It's just GCF. What's in common? Just the x. Yeah, it's just GCF. You used all that hard factoring, right? So that's just an easier one. And then you said each part equal to 0. So x equals 0 by itself, or 4x minus 1 equals 0, right? Because if 2 things times to be 0, either one could be 0 to make them times and be 0. So this one's done. This one, jump the 1 over. 4x is 1. Divide by the 4. 1/4. So our answers are 0 and 1/4 for the x values. Is that good? Questions on that? Okay, coming in the next one here, part D, if I can erase this over here. Part D says, what's the domain? What did we learn about domain? You look for 2 trouble spots, right? That makes sense from yesterday? Or 2 days ago, or whenever? That was yesterday, maybe? I don't know. Domain. What do we do for domain? We look for 2 trouble spots. Number 1, any denominators. We say denominators, you can't be 0, and we solve, right? Number 2, if you have the square root, inside. If you have inside of a square root, you say inside you've got to be greater than or equal to 0. Because you can't be negative in a root. You got to be greater than 0, positive, or equal to 0. 0 is okay. So does this function, have any denominators? No problems with denominators because he's got no denominators. Does he have any square roots? No problems with square roots because he doesn't have any square roots, so he's got no problems. So what's his domain? Negative infinity to positive, right? Otherwise, remember domain, otherwise anything goes, right? We're looking for trouble spots, and if there are no trouble spots, there's no troubles. Then you can plug any x value you want in there. What we're saying when we say the domain is negative infinity to positive infinity, we're saying you can plug any number in for x you would like. Any positive number, any negative number, any fraction, any decimal. It doesn't matter at all. There's nothing that's going to cause him a problem because he doesn't have any square roots where you have to worry about not making the inside negative, and he doesn't have any denominators where you got to worry about making the denominator 0. He doesn't have any of those problems. So he's fine with anything. Domain is negative infinity to positive infinity. List the x intercepts and then list the y intercepts. Okay, so how do we do that? How do we find the intercepts without a picture? What do we do?
Set the equation equal to 0.
Yeah. Do you know that intercept points always have one of their numbers 0? Right? Do you remember that? Just think about, I don't know what this picture looks like, but just think about if you've got some kind of graph or whatever, suppose it's that, I don't know what it is, but just think about these points. Those are intercept points, right? Places it hits the grid lines. One of the coordinates, at the coordinates, one of the 2 is always a 0 when you're on a grid line. You aware of that? I don't know what this, maybe this is over 3, up 0, I don't know, I'm just guessing. Maybe this is back 2, up 0, but see how the y values are 0? And this dot here, this is over 0, down 3 or whatever. See how his x value is 0? So one of your values is always 0 when you're on a grid line, when you're an intercept point, huh? So that makes us realize, oh, you guys want me to find intercepts. And notice this is the x-axis. At the 2 x-intercept points, the y coordinates are 0. Did you catch that? At the x-intercept points, the y values are 0. Opposite letter is 0. And at the y-axis, this is the y-axis, the x is 0. So at an intercept point, the opposite letter is 0, isn't it? Right? If you're on the x-axis, your height is 0, so your y-coordinate is 0. If you're on the y-axis, your x is 0, because your right and left 0. So with all that in mind, we think, oh, you want intercepts? I just make the opposite letter 0. You want x-intercepts? I'll just plug in y0. And I'll find them, right? Because at x-intercepts, y is 0, notice. And then when I get to the y-intercept question, I'll go, oh, you want y-intercepts? Make x 0. Because notice x is 0 at a y-intercept. Right? Everybody see that? So you don't have to draw that graph. I don't even know what this thing looks like. I'm just saying that's a generally true fact of any graph. So let me write that out then. So what we know, so part E, to find x-intercepts, set y equal to 0. And to find y-intercepts, set x equals 0. So here we go. Take our little equation, y equals 4x squared minus x minus 3, and put in 0 for y. Everybody good to there? So far, so good? So we need to solve that now. How do we solve that? Factor, if you're good at factoring, that's a harder factoring one. Or if you don't like factoring, what could you do? Look on your neighbor's paper. No, not a good idea. Quadratic formula, right? Quadratic formula, right? So either one, I'll do the quad. Maybe I've noticed over the years people like the quad, so I'll do the quad. So negative b plus or minus square root of b squared minus 4ac all over 2a. Plug into the quads. This is a b. B is negative 1, huh? C is negative 3. So negative b, negative 1, plus or minus square root of b squared, a1 squared, minus 4 times a, times c, all over 2a. So what is that? 1 plus or minus the square root of 1 plus, is that 48? I think it's 48. Notice the sign there's positive, guys and gals. You all see that? Negative times positive times negative. Comes out positive, huh? Two negatives, right? Two negatives. Positive. So we get 1 plus or minus root 49 over 2. 1 plus or minus 7 over 2. So 8 over 2 and negative 6 over 2. What's that? Oh, thank you. You're right. Thank you. 2 times 4 should be 8 on the bottom. Thanks. So then this should be, come up here, and I'll say, so it's 1 plus 7 over 8, or 1 minus 7 over 8, right? Because it's plus or minus, and this is 7. It's a funny looking 7. So 1 plus or minus 7. So that's what? 8 over 8, which is 1. This one is minus 6/8, which is minus 3/4. So the two x-intercepts are 1 and minus 3/4. You could have also gotten it by factoring. Is that good? And then, can somebody tell me the y-intercept?
Negative 3.
Negative 3, done. Do you see that? What?
Because all the x will be 0 anything time.
Exactly. Does everybody see that? Question F, y-intercept, what do? Set x to 0. So if you take this equation, you put in 0 and 0 for x, what does y equal? Just negative 3, huh? See how easy that one was? Way easier than the other one. Everybody see that? So the x-intercept was a lot of work. I mean, y0 had to solve this, did the quad, got 1 and negative 3/4. But for the y-intercept, you always set the opposite letter. Set x to 0, which means plug in 0, plug in 0. Y is just negative 3. So we got it. We good with all those? All right. So they're giving me. So I'm going to skip A. You would just plug it in, right? Come on, A. That'd be easy. I'm going to go to B. I'm going to skip B also. C. I'm going to go right to C. So part C says if f of x equals 2, what is x? What is x? So if f of x is 2, what is x? So f of x is that whole fraction thing there. And they're saying that equals 2, right? Solve for x. You tracking with me?
It's minus.
So that equals 2. So I'm going to solve that little equation for x. You good with these kind of things? There's a couple ways to do this. Cross multiplying is nice. I'll just put 2 over 1 and go diagonal, diagonal. It's one good way to go. Or you could just multiply both sides by x plus 2. It's the same effect. Am I confusing? Yeah, maybe I'll just do it that way. Either way is totally good. Let me just go back. You guys are in higher class, so I won't. I'll do a more mature thing. I'll just multiply by x minus 2 on both sides. Same thing. It's the same result either way. It just cancels it out there. So you get x plus 7 is 2 times x minus 2. Like that, right? So when we have denominators, we always just multiply both sides by that denominator. Right? Pretty much how we handle it. Distribute it on through here. So we get x plus 7 is 2x minus 4. Like that. Got to solve for x now. X is saying I want to be alone. So what do we do?
Isolate x.
Yeah. Don't worry about the 7 and the minus 4. We're focused on the x's right now, huh? So yeah, just get rid of one of these x's. It doesn't really matter which one. I'll just go minus x. So that one's gone. So I could have done the other one. Doesn't matter. So this will be 2x minus 1x is 1x. Minus 4 is 7. X wants to be alone. So add 4 to both sides. And x is 11. Is that good? You remember all that kind of stuff? Part C. What is the domain? Oh yeah, maybe we better do domain. X intercepts, Y intercepts. Yeah, that's... So what's the domain? Let's come up here. So domain. So looking at that, what do we do then with domain? Remember, we look for the trouble spots. We look for square roots. Don't got any of those. Look for denominators. We got one of those. What do we do? Denominator not equal to 0. Right? Can't let the bottom be 0. It's a big no-no. So move that 2 over. X cannot be 2. Anything else is fine. You just can't let x be 2. It can be any other number you want, but not 2. It can be 1.9999 or 2.001, but not 2 right on the money. Any other number is fine, positive or negative, just not 2. So that's the domain, anything but 2. You can plug anything but 2 into that function. And the x-intercepts and the y-intercepts, that's not going to be any kind of big deal, I don't think. On that one, I don't think you're going to have any trouble. Is it true? Yeah, let me do that. Well, let me do one of them with you. One of them could be tricky. The x-intercepts. I remember it being tricky in the past. So, part E, last one we'll do here. X-intercepts. Okay. How do we find x-intercepts?
Set y equals 0.
Set y to 0. Remember, it's opposite letter. Good thing to put in your 3x5 card for the exam. Right? X-intercept, make y 0. Y-intercept, make x 0. Good thing to have in there. Set y to 0. So I take the equation they gave me, y equals x plus 7 over x minus 2, and I put y in as 0. Good to there so far? Good. Okay, can you take it from there? Go ahead and solve for x. I just want to make sure you're okay with solving for x from there. What do we do? Yeah, multiply by the denominator, right? And both sides, right? Got to keep the balance. When we do to one side, do the other. Keep the balance. Over here, it cancels. Good. And so we get what? We get x plus 7. And what's 0 times anything? No, it's a 0. Move the 7 over. X is minus 7. We good? Questions on that one? That's all we seem to have time for. All right, so on this one, it says, I'm going to skip part A, part B, go down to part C again. F of x equals 1. What is x? So what is x? So I take this function f of x, and I put in 1. We good to there? So I just plugged in 1 for f of x. Now, can you solve that? Let me give you a second. So go ahead and solve that equation for x. What's the first step? And multiply by the denominator, x to the 4th plus 49. Like that. Come over here. X to the 4th plus 49. These cancel. 14x squared, good to there. Now, what do we do with, this can be a little confusing now, what do we do with these higher power things, like x to the 4th, x squared, things like that? Get a 0. Yeah, you just do the 0 thing again. Yeah, we can't do the square root thing because we have other x's. Yeah, the only time you can do the square root thing is if you just have x squared and straight numbers, no other kind of x thing. You tracking with me? I know we did that and it can be a little confusing, so one more time. If you have x squared and only numbers, yeah, then do the root thing, you know, where you get it alone. But if you have like a couple of different x powers, you got to do the 0 and try to factor. So I'm going to jump this guy over and get a 0. It becomes a negative, right? When you jump something to the other side, change the sign, right? And then factor that. Factor that just like you would x squared, except it's x to the 4th, just double. You could even do the quad if you wanted, but this one's factor's easy. I think I would just factor it. What times what makes x to the 4th? X squared. We good so far? And what times what makes, remember, they got to multiply to be the one at the back, and they add to be the one in the middle. Remember how the factoring works? 7 and 7. What signs do we need to make a multiply to be positive, yet add to be negative? Both negative, right? Because two negatives will multiply to be positive, and they'll add to be a bigger negative. So that's right. Now, what do you do from here? When you have timesing things equaling 0, what does that always mean? Any one of them could be 0 to make them all times out to be 0, right? So the first one could be 0, and the second one's the same, so you don't really need to write it again. It's just going to have the same answer. No point. So I'll just solve this one. How do you solve? Now I do have this, don't I? This is just x squared and numbers. So yeah, that just when you have that, I was a little abrupt here. It should really be get x alone, or x squared, I mean. Get x squared alone, and then do root and plus or minus root. Right, that's what we do when we just have x squared and numbers, no other x things, right? So I'll just jump that 7 over. Becomes a positive regular 7. And then we do the root. And don't forget plus or minus, because x squared, there's plus or minus options, right? So plus or minus root 7 on that. Those are the two answers.
Do you have to do the sign greater than or equal to? Like, because you use a square root.
No greater than or equal to. No, nothing like that. No, it just stays equal. Yeah, just stays equal. Does it make sense? I hope it makes sense. It's not just something Mr. Heron says. Right? If you put in square root 7 there, squared, that is 7, isn't it? Or even right here. If you put in square root 7, squared, that's 7, minus 7, that is 0, huh? That's true. Or negative. Negative root 7 squared is still positive 7, right? Negative squared is positive. Minus 7 is 0. See, those are true, aren't they? Those really are the two right answers to that. Good on that one. And then, bless you. Unless the X intercepts, set it to 0. Is that going to be hard? No, that'll be easy. Those are easy. So I'm going to move on. You're okay? I'm going to go to 9 and 10. Or that is 10. 11, 12? 12, I mean, I'll do 12 if that one's harder. Does anybody know? Nobody knows? I just don't remember. All right. We'll do this one, I guess. Okay, F plus G of 4. So they're giving me two graphs here, F and G. Looks like G's the blue one, and F's the red one, I guess. This is, oh, yeah, it says right here. There, yeah, F is the red one. See right here, G's the blue one. Okay, so anyway, they want F plus G of 4. Well, what that means is F of 4 and G of 4 added together. Okay, how do I do that? Remember, what's plugged into any function is always x, and what it equals is y, like when we started this hour, right? What you plug into a function is x, the answer that comes out is y. That's the key to reading a graph in function notation. So they're saying, find x value 4 on the F graph, the red graph, and tell us what the y value is there. So here's x value 4 on the red graph. What's the y value? 5. Good so far? How about for G? Go to the blue graph, the G graph. find the x value for, right here. What's the y value? 0. 5 plus 0, 5. So the key is knowing that when somebody writes f of 4 and they're giving you a picture, they mean find x4, find the y value that goes with x4. That's what they're saying. I hope all the rest of the questions are just as easy, but we're out of time. So this is due. We can't hold up anymore. 2.2 will be due, what, tomorrow? Thursday at class time. See you tomorrow. Hang out if you got questions. Be glad to help.